Okay, now we're recording. All right, guys. So here we go. We're gonna review some pre-cal. It's a review, so you should already know it. So let's see how much you learned. Here we go. It says find the x and y intercepts in the domain of the range, and then sketch the graph. So here's my function. Okay, it's y equals x squared minus x minus 6 over x minus 3. So can anybody tell me what type of function this is? What type of function? When I say what type of function, what am I looking for? Like the parent graph. Do y'all remember your parent graphs? Like what are the different types called? Yes, no, maybe so. No, no, no. Is it quadratic? Is it cubic? Is it a radical function? Is it a sine function? Is it cosine? Is it rational? Is it those are all your options. Is it an absolute value? It's cubic, you say? Guys, what does it look like? It looks quadratic? Okay, so why did she say it looks quadratic? So it has an x squared, right? That's usually your biggest red flag of that it's quadratic, is that it has x squared. Does everybody agree? The only difference is that this has an x squared. What is this? It's a fraction. It's a fraction. What's the fancy word for a fraction? Starts with an R. It's a ratio. Ratio is the fancy word for fraction, right? A ratio. So this is a fractional function, but we don't say fractional function. We call it a rational function. This is a rational function. And if you look at the word itself, what is the front part of it? It's a ratio, right? So any function that looks like a fraction, as long as there's an x in both the numerator and the denominator, it's a rational function. Okay, so this is a rational function. Does anybody know what a rational, just in general, what a rational function will look like? Maybe before you start manipulating and all that. Does anybody? I'm asking you if you know what your parent graph is. No? Y'all remember these? Remember those? So these are your, that's what a rational function looks like. Okay, so that's what a rational function looks like. So now that you see it, does it involve other things? Do other things happen here when you have rational functions? Like some interesting things happen. Like if you look at your x and y axis here, in this case, they act as what? Kinda, what's the word? You said it too. It never touches them. What is that called? Starts with an A? Asymptotes. You guys remember that? Asymptotes? So do y'all remember the three types of asymptotes that we have normally? Vertical, horizontal, and slant asymptotes. Good. So those are the asymptotes that we normally have. In this case, I only have a vertical and a horizontal. If you took it summer pre-cal, we call them the ha's, the va's, and the sa's, right? Horizontal, vertical, or slant asymptote. So in this case, there are going to be some asymptotes here, right? I'm not asking you about them right now. I'm more concerned with x-intercept, y-intercept, domain, and range. So let's talk about an x-intercept. What is an x-intercept? Pretty much exactly what the name says. It's where it crosses the x-axis. Simple as that. Do we call it something else sometimes? Call it zeros? Roots? Or I heard solutions? Basically, guys, all four of those words mean the exact same thing. If I say, hey, find the solutions, or find the zeros, or find the roots, I'm asking you to do the same thing. I'm asking you to find out where this graph crosses the x-axis. Got it? All right. How do I do that? How do you find an x-intercept? Good. Because if you think about it, look, here's some random graph. At every point, I don't care where it is, at every point, I don't even have to know the numbers. All I know is that at this point, what's my y value? 0. At this point, what's my y value? 0. At this point, what's my y value? 0. So does everybody agree at every x-intercept, y is always what? 0. Good. So at every x-intercept, y is always equal to 0. Does everybody agree with that? So how then, if I have given an equation like that, how do I find the x-intercepts? You set y to be equal to 0, and then you're going to solve. Okay? Is this coming back a little bit? Okay. Now, but with rational functions, something interesting happens. Because if I make this equal to 0, then it's going to say 0 equals to all that, correct? But the thing with rational function is there's one part of it that I never want to be 0. What? Someone said it. What? The denominator. You never want the denominator to be 0. Why? It's undefined because remember, you said it earlier, ratios are just division. And what can you never do? Divide by 0. You can never divide by 0, right? So does everybody agree that I don't want the bottom to be 0, correct? I don't want the bottom to be 0. So in this case, I can kind of ignore it. I don't need to know when that's going to be 0 because I don't want it to be 0. Does everybody agree? So I'm only going to pay attention to numerator. I'm only going to pay attention to my numerator here. And so basically, I need to figure out where does the top part equal to 0. I need to figure it out. I need to solve. Where is the numerator going to be equal to 0? Okay? How? How do I do this? There's a couple of ways I can do this. Factoring is one of them. So I can factor. Does everybody remember what factoring means? What does factoring mean? Break it apart. If I ask you for the factors of 12, what am I asking? Give me two numbers, right, that multiply to give me 12. So when I ask you to factor an equation, what type of equation is this, by the way? Just this? This is quadratic. How do you know it's quadratic? It's x squared. Does everybody go with that? So if I ask you to factor a quadratic equation, I'm asking you to break it down into two smaller equations that when you multiply will give me this, correct? So I can factor. Good. There's another way I could solve for x here. What do you mean? Oh, just like trying a bunch? I mean, you could. Yeah, you could. You can try a bunch of like that's like a test method, right? I mean, nothing wrong with that. You're basically he's saying you could just try numbers to get what? What are you trying to get? 0. You were trying to get 0. Okay, you could do that. Might take a long time because what if it's not a whole number, right? What if it's a half? We normally don't think of trying every decimal between. So I know I can factor. There's one more way, and it's like your favorite way, I promise. Does anybody remember the quadratic formula? What's the quadratic formula? The negative b plus or minus square root. Ain't nobody got time for that. So y'all remember that? The negative b plus or minus square root b squared minus 4ac, all that over 2a? Do y'all remember what that's for? It's solving for x, right? Do I know an a, a b, and a c? Yeah, what's my a? A is the number, so what's my a? 1. What's my b? Negative 1. And what's my c? Negative 6. So I know a, I know b, I know c, correct? So I could, if I wanted to, use that formula, right? Because that one works all the time, right? So good, I could do that. That would be actually the longest way. I'm actually going to go with what Amanda said first. She said factor, so because factoring is the easiest one. Does everybody remember what factoring looks like in the end? So, looks like the two parentheses, right? Looks like the butt cheeks, okay? So basically, you want to break them down into the butt cheeks. You have two parentheses, and you're looking for two smaller equations. We're used to seeing something like x plus or minus some number, x plus or minus some number, right? Agreed? Now, how do we get those numbers? Very good. So if you were in my summer pre-cal or my pre-cal last year, I gave you a method that works all the time. And it's a very simple method, and we all need to remember it when we're factoring. So here's the first step. The first step is always multiply a and c. What's my a again? 1. And what's my c? So multiply them. What's 1 times negative 6? Okay, keep that number, right? So second step is find multiples of that number that add up to b. So I need multiples of -6 that add up to, what's my b? -1. So give me two numbers, guys, that multiply to give me a -6 that add to give me a -1. -3 and 2. Does everybody agree with that? Okay, so does everybody agree that I know it's going to be a -3 and then I'm going to have a +2, correct? Now the last part is always to put your x, your variable. So now we're used to just seeing an x, but here's the trick. You're always going to put your ax. So what was my a in this case? 1. So it's going to look like there's nothing there, but if there were a 2, I would put 2x. If there was a 3, I would put 3x. If there was a 4, I would put 4x. Now, in this case, it doesn't matter, so it's just going to be x. It's just going to be x minus 3 times x plus 2. Now, why do I have to put that a? Because your last and final step, if there was an a here, if there was an a, you would have to reduce. So you would look at this. So let's just, for example, let's just pretend that this was a 2x, okay? Let's just say this was a 2x. So if I looked at this here, and it said 2x minus 3, just looking at that, could I reduce that? No, 2 and 3 can't be reduced, right? They're different numbers, right? But what if over here, if I had 2x plus 2, could I reduce that? Yeah, they both can be reduced by 2. So that would turn it into an x plus 1, okay? So sometimes there's always going to be that last step. Now, here's the thing. You have to reduce. If you can, you have to reduce. Because if you don't, then you did everything wrong, okay? In our case, we don't have to because there's a 1, right? So there's no big deal. We good? Does everybody remember how to factor? Okay, so now I have it factored, but I haven't solved yet. What's the last step? Separate and solve. Basically, guys, here's what you need to understand. I have the first thing times the second thing is equal to what? 0. Go back to elementary when you first learned multiplication. If you have two things that multiply to give me 0, well, there's only one way to do that. One of them has to be 0. Or both, right? One or both, because 0 times 0 is still 0, correct? So we're going to take that knowledge and use it. If I'm saying that this times this is equal to 0, then this is 0 by itself, or this is 0 by itself. Agreed? Well, what's going to make this 0? +3. So I already know that x is going to be a +3. And what's going to make this 0? So then I know that x is going to be a -2. So there you go. Those are, what did I just find? My x-intercept. So I already know that I'm going to cross the x-axis here at -2 and at +3. Very good. Let's move on. Next thing I want to know is my y-intercept. How do you find y-intercept? Good. So if you found x-intercept by making y 0, to find the y-intercept, you make x 0. Now this one's pretty simple because if I make x 0, what happens? So I would plug in a 0 everything. What's going to happen to these? They're basically going to go away. Does everybody see that? So for my y-intercept, when x is equal to 0, what do I get as my y? If this is 0 and this is 0, what's left? So you get a -6 over, if this is 0, what's left? -3. Can I reduce that or simplify that? 2. This is just a +2. So my y-intercept is a +2. So I know up here, it's going to be a +2. We good? All right, let's move on. What's domain? Can somebody explain domain to me? It's not a list because I can't sit here and make a list, but you have the right idea. Domain is what? I know everybody knows. You're just afraid to say. Domain is which part? The x's, and range is which part? The y's. Now we got to be a little more specific because I can't just say x's and y's. Domain is the possible x's. Now, what do I mean by possible? Well, let's put it this way. If there are possible x's, then there are impossible x's. What would make a rational function impossible? You said it earlier, Stan. If it's what? Starts with a U. Undefined. right? So guys, what x would make this function undefined? What does it mean to be undefined? No. Say that again. The denominator is 0. So it's undefined when the bottom is 0. When the bottom is 0. Now, remember, I found this part, but I only paid attention to the what? To the top, right? I only paid attention to the top. So when I come into my domain here, now I really only care about the bottom. Do I care if the top's 0? No, if the top's 0, who cares? Whatever. 0 divided by whatever is still 0. 0 is a number. But when I get 0 on the bottom, that's where it's undefined. That's an issue. Okay? So this is very simple, guys. Looking at my denominator, what x value is going to give me 0? 3. So guess what? Can I have that in my domain? No. So how do I say that? How do I say my domain is everything except 3? I can't list here. So there's a couple of ways. Yeah. So there's a couple of ways. I'm going to do this. The simplest way is this. The domain is, does anybody remember this symbol? All real numbers, which means what? Everything. Every number you can think of. Positive, negative, zeros, fractions, decimals. That's what all real numbers are. Okay? Pi, e, all of those are part of all real numbers, right? So that's technically every number in existence that we can think of. Now, why do I have to say real? Why can't I just say all numbers? There's imaginary. So am I including the imaginaries? No. That's why I say all real numbers, right? So I'm saying all real numbers except 3. So how do I say that? Well, I say all real numbers where x does not equal to 3. So that's probably the way you've seen it. That's probably the most likely way you're going to see it. Another way is through interval notation. Interval notation, you guys remember the whole brackets? It looks probably like this. Negative infinity to 3, and 3 to infinity. You guys remember that? Okay, so is there a difference between a parentheses and a square bracket? What's the difference? The bracket is included. The parentheses is not included. Because notice, when I did this parentheses next to the 3, do I include the 3? No. How do I not include 3? What does that even mean? How do you not include 3? Then why write it down? What does it mean to not include 3? Because isn't it easier to say this, 3 but not including 3, than to write 2.999999999 all the way to an infinite amount? Can I even do that? Is that even possible? No, it's impossible for me to write an infinite amount of 9s. So I just say 3 but just don't include it. Does that make sense? Okay? And then the same thing here. That's why we also do not include ever my negative and positive infinity. You'll never include those. Why? Can you ever get there? Can you ever get to infinity? No. Because if you say, hey, I got to infinity, I can just say, oh, I add 1. Now that's infinity. But then I could say, oh, and I add 1. Or that's infinity. You see what I'm saying? So you'll never include infinity. So that's the domain. That's the domain. And then basically it just means all my x's except 3. Okay? You can't include 3. And then what's range then? The y's. And again, it's the y's. It's what's the lowest it goes, what's the highest it goes. In this case here, I'm going to give you a hint. Here's the graph. This is what the graph looks like, okay? And there's an asymptote there. So what's the lowest this thing goes? What does this mean? Forever, which is what? Negative infinity. And what does this mean? So then basically the range is everything, right? For range, guys, and I'm always going to tell you this, see graph. The graph is the easiest way to figure out the range, okay? So you would always, in this case, I have the calculators up, and I really don't feel like passing them out right now. But I would tell you to graph it and look at the picture. That's the best way to see a range. To try and do it algebraically is kind of bothersome and time consuming. So we'll just kind of always tell you to. But everything else, notice I did everything else by hand. I can do everything else by hand. Okay? Are we good? Is this kind of coming back a little bit? Is anybody like, what the hell is he talking about? Yeah? Alright, well. The thing is, we got to keep trying. Okay? Don't look. Okay. Let's try again. I'm switching it up now. Same function? Same function? No. Does anybody know what this one's called? A radical function. Why? Good. This is called a radical function because it has a radical. Does everybody realize that that's what this symbol is actually called? Right? This is not called a square root function thingy. Because why? Is it always a square root? No, it could be a cubed root. It could be a fourth root, fifth root, 10th root. But in this case, how do I know that it is a square root? Remember the little index number that's supposed to be here? If there was a 3 here, then that means cube root, or 4 or 5, whatever, nth root, right? But if there's nothing, by default, it's always square root, right? So this is actually a square root function, okay? So, but we call it a radical. So from now on, guys, in calculus, this is called a what? A radical. Does anybody know what I call the stuff on the inside? Radicand, A and D, radicand. So the stuff on the inside is your radicand. So the radical is the symbol, the radicand is the stuff on the inside. So, does anybody have an idea of what this even looks like? A radical function? Who knew you had to remember so much on the first day, right? A radical function, people, looks like this. You guys remember that one? To me, it kind of looks like a parabola that fell over, but the bottom half is cut off, right? So it's like a parabola that fell over in the bottom half. So it kind of looks like, what is it doing, by the way? It's going to the right and up, right? It's going to the right and up. It's just not straight. It's not like a straight line, but it's going to the right. It's going to the right and up, just like Amanda said, never stopping. So it's going to what? Infinity. Can somebody tell me, give me some other interesting features about this? You should be able to look at this and at least tell me some things. Okay, starts at 0. What else? There's no intercept. Technically, that one has 1. I see why you would say that, though. What else? You should be able to tell me this, people. What do you notice over here? There's nothing. So there's no what? There's no negative x's, right? There's no negative x's. Also, look at the bottom. There's no negative y's. So you can already, when I'm talking about x's and y's, what am I talking about? Domain and range. So you're kind of already figuring out the domain and range. So the domain, based on this picture, this is not the one we're dealing with. This is in general. The domain, you can already tell me, is all positive numbers, and the range is also all positive numbers. Okay, so you should have that stuff kind of in mind already. Now let's take a better look at this one. Okay, let's take a better look at this one. So, how do you find an x-intercept again? You set y to 0. So, I'm going to take my equation. The square root of x plus 3 equals to 0. Do me a favor and solve for x. When you solve for x, what are you doing? What are you trying to do? You're trying to what? Good. Mia said she's trying to get rid of the radical. Why? What's the point? When you're solving, guys, what's the point? What are you trying to do? What's the end game? To get that x by itself, alone. You're trying to get that x by itself. And so Mia and, what was your name? I'm sorry. Michael. Mia and Michael both had said the same thing. They're trying to get rid of that radical. Now Mia said get rid of the radical, and Michael said how? How are you going to get rid of a radical? You squared. You got to do the opposite, right? To get rid of stuff, you always do the opposite. If you're adding, what are you going to do? If you're multiplying, what are you going to do? If you're square rooting, well, what's the opposite of square rooting? Squaring. If it was a cubed root, you would what? Take it to the third power. If it was the 10th root, you would take it to the, and vice versa, right? To get rid of a exponent of 2, you would square root and stuff like that. So in this case, does everybody agree that I'm going to square it? But of course, whatever I do to one side, I got to do to the other. Now, if I square the left side, what happens? The radical just goes away. Radical just goes away. So I'm left with what? Equals, well, 0 squared is still 0. And now it's real simple. So this is my x-intercept. This is my x-intercept. So looking at this kind of graph, and we said it earlier, if that's my x-intercept, what is that kind of telling me? That this is where this graph what? That's where it starts, right? So at 1, 2, I'm sorry, it's negative, right? 1, 2, 3. So does everybody agree that this is where this graph is going to start, and then it's going to basically do the same thing? Go up like that, go up and out like that, right? So that's what it's going to do. Let's try and find my y-intercept. How do you do the y-intercept? What would that look like? What's 0 plus 3? So y equals the square root of 3. Do you know the square root of 3? So then, do you know what to do? Just leave it. Can you give me an approximation? Yeah, it's like 1 point something, right? So does everybody agree that this is also, right, it's going to cross the y-axis above or below 1? Above 1, but below what? Why? How do you know it's below 2? Because the square root of 4 is 2, right? So it's obviously in between. So I know it's going to be between 1 and 2. Does that make sense? Okay? So there's my y-intercept. And we already talked about this before. What's my domain going to be? All the possible x's. Well, look, I know I can't be, they're not supposed to be negative, but look at where my graph is. What's the furthest left it goes? And what's the farthest right it goes? So then how could I write that? How could I write from -3 to infinity? He said bracket 3 to infinity. Is that? Why do I have to put a, I'm sorry. Why do I have to put a bracket? I can actually include that point this time, right? If I include -3, it's not going to give me a problem, because if I plug in -3, what do I get? What's 0? And what's the square root of 0? 0. Can I get that? Is that okay? Yeah. It's not like the other one where it gives me undefined. The square root of 0 is 0, so it's an okay answer. And based on this, what's my range? What's the lowest it goes? 0. So notice here, you're looking at the y's now. The lowest it goes is here, correct? And then what's the highest it goes? Again, because it's going up. So how would do I include 0? So what would that look like? 2 infinity. Good? All right. I'm going to cut the noose.